In this section, we'll understand why load balancing came into picture. What were the driving factors of load balancing? Before any hardware or software solution came into picture, what was used to achieve load balancing? A typical infrastructure with no load balancing would look something like this, where a user is trying to access the application over internet. The request goes to the web server, and the web server is trying to communicate to the database server at the backend. These web servers, which host your application, come with limited capacity, be it in terms of memory, CPU, RAM, anything. So initially, when you host the applications on the web server, the performance might be very good because of the number of users who are using it. As your applications become more and more famous and more people are trying to access the application, the load on the server keeps on increasing. So in that scenario, the developer would look for a better solution and would try to have the infrastructure in such a way that the performance of the end user is not impacted in any way. Let us try to understand what exactly is load balancing. It is the entire intent to create a virtualized service, and we separate the services which are actually hosted on the backend servers. So let us assume that you have three servers. The IP address of 172.168.1.2, 172.168.1.4. So what I'm trying to do is, even though the services are hosted on all these three servers for port 80, I'm trying to, instead of exposing all these three IP addresses to the outside world, what I'm trying to do is I'm trying to create one IP address and one port, and this will be acting as the front end to the end users. My entire intent of load balancing is to create a virtualized system and represent the services in such a way that it represents all these three servers. A more basic definition would be to balance the load across a bunch of physical servers so that it looks like one big server to the outside world. When we talk about load balancing, the primary drivers of load balancing are scalability, high availability, and predictability. Let us discuss about these terms. Scalability. It is the capability of dynamically adapting to increased load without impacting any existing performance. So let us say on day one, you have only server one, and this is the client who is trying to access the application. This server comes with a limited capacity, be it in terms of CPU, memory, RAM, and according to the capacity of this server, it can handle maybe 1 million requests per second. If the number of requests which keep coming to these servers goes beyond this or even reaches close to this, the end performance of the application will get degraded. I don't want that in my infrastructure. So I would plan to introduce another server, be it server, two servers or three servers in my server farm without impacting the existing performance. So this is called as scalable. Your infrastructure should be scalable at any point of time. Next component is high availability. In today's world, it is very important that all your applications are available all the time. 100% availability is a must for each application. Specifically in banking sectors, if you think of one website going down even for a 1 minute, how much loss it would bring and the brand impact it would bring to the banking sector. So we need to ensure that my website or my application remains available all the time. So in order to address this, again, my load balancer came into picture, which made sure that if server 1 for some reason the service is not working or isn't in hung state, the load balancer does not send my client connections to this server. Instead, it would send it to server 2. So at the back end, the load balancer will monitor the instances of the server and ensure that your end application, when a user is trying to access the application, it is not impacted in any way. And when in my environment I combine scalability and high availability, my infrastructure basically becomes predictable. So predictability is the next factor which comes into picture when I design load balancing. It is the capability of having confidence in how your applications are getting delivered with regards to performance and so on. So in the beginning, when there was a initial requirement of load balancing, DNS was the solution. So in DNS, what was performed is two records were created corresponding to your application. Let us assume that user is trying to access example.com and this example.com application is hosted on two servers. So what was done on the DNS server is two A records were created corresponding to this domain name, resolving to 11 192.0.2.11 and 192.0.2.12. So when a first query is initiated from the client machine towards the DNS server, the DNS server in response gave back the response as .11 and .12, and when the next request was initiated for the DNS query, it gave the response as .12 and .11. So basically the user tried to access example.com. The DNS server would handle back multiple addresses, one for each server that hosted the application in order of record creation. The next time when the DNS server would give back the same address, it would give it in a different sequence. So your client would try to connect to the first preferred IP address. This was quite basic solution which met the initial requirement. But overall, this was not the permanent solution. The reason being, at times, the DNS server responded back with an IP address which is either down, not reachable, or the service is hung. So that did not meet our expectations. That is when the need to design a software or hardware based load balancing came into picture. So in here, as you can see, the physical server are 172.16.1.11 and 1.12. In front of these physical servers, a load balancer was deployed and a virtual service was created, which was the front end to end users. And at the back end, we have these group of servers. This completes our load balancing section. I hope this has been informative to you. Thank you for watching.